Hey science fans, look around you. What do you see? Your chair, your lunch, your best friend? Guess what? All of it, every single thing is made of atoms. Yes, even you. Atoms are like super tiny Lego bricks. They are the basic building blocks of all matter. So, what exactly is an atom? Think of it this way. If you take a piece of gold and keep cutting it in half, eventually, you'd get to the smallest piece that is still gold. That tiny piece is an atom. An atom is the smallest unit of an element. Now here's a mind blower for you. Atoms are mostly empty space. Imagine a giant sports stadium. The nucleus, the atom's center, is like a marble in the middle of that huge stadium. The rest is just space. But that tiny center has almost all the mass. Understanding atoms is like having a secret key to understanding the whole universe. Let's zoom into that tiny center. We call it the nucleus. Say it with me, nucleus. It's small, but it's mighty. Inside the nucleus we find two types of particles. First up are protons. Protons have a positive electrical charge. The number of protons tells us what element it is. Next in the nucleus are neutrons. Neutrons are neutral. They have no electrical charge. They add mass to the atom and help hold the nucleus together. Without them, those positive protons might push apart. Science is all about balance. So, how does this tiny nucleus stay packed? With all those positive protons trying to repel each other, there's a super-duper force at work here. It's called the strong nuclear force. It's one of the most powerful forces in nature. Imagine it like super strong glue, holding the protons and neutrons together super tight. The nucleus is tiny, but it's packed with power. Alright, we've met the nucleus crew. Protons and neutrons, check. But what about the rest of the atom? Remember all that empty space? Whizzing around the nucleus are electrons. Electrons are super tiny particles. They have a negative electrical charge. They are much smaller than protons or neutrons, and they move incredibly fast. Zoom! These electrons don't just wander anywhere. They orbit the nucleus in specific paths called electron shells or energy levels. Think of it like planets orbiting the sun. Each planet has its own orbit, its own lane. Electrons are similar. They stick to their designated energy shells. The electrons in the outermost shell are super important. These are called valence electrons. They are the reason atoms can bond together to form molecules and all the stuff around us. Cool, huh? Section 4. Atoms' ID numbers that really count. Every element has its own special ID. This ID is called the atomic number. The atomic number is super simple. It's just the number of protons in an atom's nucleus. For example, hydrogen has 1 proton, so its atomic number is 1. Helium has 2 protons, its atomic number is 2. Carbon has 6 protons, atomic number 6. This number defines the element. Now let's talk about an atom's weight. For this we use the mass number. The mass number is the total count of protons plus neutrons. Sometimes atoms of the same element can have different neutrons. These are called isotopes, like carbon-12, 6 protons, 6 neutrons, and carbon-14, 6 protons, 8 neutrons. Same element, different weight. All these elements with their atomic numbers, they are organized in an amazing chart called the Periodic Table of Elements. It's a masterpiece of scientific organization. Section 5. Atoms in action. Why this tiny stuff is a big deal. So why is knowing all this atom stuff so important? Understanding atomic structure is key to chemistry. It helps scientists predict how different atoms will react. When they meet each other, will they bond? Will they swap electrons? Will they make something new? It's like knowing the rules for mixing ingredients to bake an awesome science cake, or to create new medicines or materials. It all starts with the atom. Speaking of new materials and medicine, knowledge of atoms helps us build amazing things. Engineers can design new materials that are stronger, lighter, or that can conduct electricity, or even glow. Think about plastics, alloys, or even computer chips. In medicine, understanding atoms is crucial. Things like MRI scans, magnetic resonance imaging, or PET scans, positron emission tomography, use the properties of atoms to see inside our bodies. Radiation therapy for cancer also targets atoms. Understanding atoms helps us explore space and develop new energy sources like solar power or even nuclear energy, which uses atom splitting. From the tiniest particles come the biggest ideas and the most incredible discoveries. Knowing about atoms and their structure is fundamental to so much of science. It helps us understand the world and the universe. Isn't science incredible? Go explore.